Now, we are going to be talking about the indirect pathway, which works as basically a braking system to suppress unwanted movement. So first of all, we're going to start off with a similar thing, saying that the motor cortex sends excitatory signals via glutamate to the striatum. However, and the striatum then sends inhibitory signals via GABA to the globus pallidus externus. So this is the unique part. Instead of going to the globus pallidus internus like we did in the direct pathway, we are going to the globus pallidus externus. So mapping this out, let's draw this out in red. We have the cerebral cortex in the indirect pathway sending signals to the striatum. Striatum then goes to the globus pallidus externus, the outward darker blue region right here instead of the lighter blue region on the inside. Since the globus pallidus externus is normally inhibitory, meaning that it would usually inhibit the subthalamic nuclei, essentially inhibiting it via the striatum means that it can no longer suppress these subthalamic nuclei. And because the subthalamic nuclei are no longer suppressed, they are able to send these positive excitatory glutamate signals to the globus pallidus internus and the substantia nigra pars reticulata, the S and R, to the output nuclei. And remember what these output nuclei wanted to do in the direct pathway. They want to inhibit the thalamus. And we no longer have this inhibition that we saw in the direct pathway where the striatum directly inhibited the output nuclei. Instead, here, the striatum inhibited the globus pallidus externus, whose job is to inhibit the subthalamic nuclei. But by inhibiting globus pallidus externus, we can no longer inhibit the subthalamic nuclei. The subthalamic nuclei then excite the globus pallidus internus and substantia nigra reticulata,